Hello, this is Professor C.P.PRAKASAM, former professor from International Institute for Population Sciences, Mumbai. I will be discussing about polynomial regression with an illustration by using the Excel and SPSS. The word polynomial is derived from a Greek word poly, means many, and nominal means terms, that is many terms. The linear relation between the one dependent variable y and one independent variable x1 can be established by a simple linear regression, that is y equals to b0 plus b1 x1 plus error term e. Similarly, the linear relationship between one dependent variable, that is y, and k independent variables can be established by multiple linear regression, that is y equals to beta naught plus b1 x1 plus b2 x2 plus b3 x3 and so on bk xk plus error term. If the relation between the independent and dependent variables not linear, then non-linear relationship can be established. That non-linear relationship between one dependent variable y with one independent variable x or two independent variable x1 and x2 can be established by applying polynomial regression method where x2 is derived from x1. Polynomial regression model with one variable with k order is as follows: y equals to b0 plus b1 x to the power of 1 plus b2 x square plus b3 x cubed and so on bk x to the power of k. But when y equals to b0 plus b1 x to the power of 1 is called a monomial, that is single power. Y equals to b0 plus b1 x to the power of 1 plus b2 x square is binomial, and y equals to b0 plus b1 x to the power of 1 plus b2 x square plus b3 x cubed is called the tri or cubic equation of the polynomial, and so on. Many terms or k terms can be used. One condition is that if xj equals to x to the power of j, where j equals to 1, 2, 3, 4, 5 up to k, then the above equation 1 is multiple linear regression model in kth order with x1, x2, x3 and xk explanatory variables. Therefore, there is a regression by using the least square method as well as the polynomial regression. Therefore, the polynomial model can be estimated by using the least square method. Hence, linear regression model y equals to b0 plus b1 x1 plus error term is a specific case of polynomial regression model where xj equals to x to the power of j, where j equals to 1. Therefore, coming back to the polynomial regression equation, y equals to b0 plus b1 x to the power of 1 plus b2 x to the power of 2, that is x square, plus e term is a polynomial regression model with one variable x and order 2 or the power 2 is called the second order polynomial regression model or quadratic model. Power 3, that is plus b3 x to the power of 3 x cubed is the cubic polynomial model, and so on. The importance of polynomial regression model is that it is a non-linear relation data can be set and fitted a best fit regression equation. It covers all the data points which are not in linear line, suitable for trend analysis where more fluctuations are in the data set. The polynomial regression model always fit the data more closely, may overfit when the degree is more than 3, that is cubic polynomial regression equation. It is necessary to choose the degree on the basis of the data set. Through polynomial regression model, future prediction estimations for the data set can be made, but these future estimations, if it is a long-term future estimations, that is, it gives a kind of a distorted picture, but it is quite suitable for the short-term projections or estimations. Method of fitting polynomial regression equation or regression model. There are two methods we can adopt by using the Excel or least square regression method by SPSS or state. Let us illustrate with an example. Mr. X has been selected as a general manager position with 8 years experience in reputed company. He demands 3,80,000 rupees pay pocket for the current position. Management collected the data from Mr. X for past pay to decide the present pay pockets. Following is the pay drawn by Mr. X in the past. The first year he got the 60,000, second year, third year, fourth year, fifth year, sixth year, seventh year and eighth year data is given here. Then management wants to decide whether for the current position in the 8th year he is entitled for 38K.
How to calculate the polynomial regression by using the Excel. Here, first of all, you block the data and then go to the insert, and after insert you choose the charts. In the chart, click and then see that this will give a curve pattern. Therefore, we require to find out the curve equation and then click here the line diagram. It will give a line diagram here. In this, it is given number of years and then you click on the chart area and select the data. Identify your data set. Afterwards, you select the curve, right click, add data labels, you will get that. And then right click, you will get add trend line. Once you get the trend line, go to the polynomial and click and order 3. This is the order will be selected on the basis of the researcher's information, or also we can identify by using the R square value. And we want to estimate the 9th year, therefore additionally one more year forward selection will be there, and then set intercept display R square display equation. Then you will get the equation here, and this is the number of years, and then we can give the chart title, pay scales and whatever. You can give the title here. Equation, then substitute the value of the estimated year. That is we require to estimate the next year, that is the 9th year. Therefore, your y equals to 212.27 in it is x cubed. Therefore, 9 into 9 into 9 minus 658.01 into x square, 9 into 9, that is the 9th year we are going to estimate that. And then here that is 31033 into x value is 9 here because 9th year. Therefore, the calculated value it comes to 380,743. That means the required estimated value is 3,80,743. That is 38K. That is the equation of calculating the polynomial regression equation by using the SPSS. In the SPSS, after entering the data, go to the analyze, click here and then say regression, and then say curve estimates. Click curve estimates, bring the pay pockets, that is the dependent variable, and then bring the independent variable number of years, and then say plot the model. And since we have selected the cubic regression equation, you say cubic and say display the analysis of variance table and say OK. Then we'll get the output here and slowly observe the output, the curve fitting here, and then we are interested about the cubic fit, and R square is 0.992. Analysis of variance is highly significant, and then that means it is a model fit is very good, highly significant, and these are the coefficients for the first year, for the y square, and then for the cubic values, and beta coefficients are given here, and as well as the pay pockets, and this is the graph representation which is given here. Then we have to estimate the coefficients. We have to estimate the 9th year, what would be the projected pay pocket. For that purpose, take the regression equation, copy this into the Excel sheet. From the output, which has been derived from the SPSS, then copy the output, and these are the beta coefficients, and we have to estimate for the next year, that is the x equals to 9, x square equals to 81, x cubed equals to 729. We have to estimate the value for the next year. Therefore, you substitute these values, beta 1 multiplied by first x, and beta 2 x square, beta 3 x cubed, and the summation value is obtained here. That is 380,743.8. The values which has been derived from the Excel as well as the SPSS.
After estimating the polynomial regression equation by using the Excel or SPSS, we have to estimate the value for the current year, that is the 9th year. Therefore, substituting the value in the equation, y equals to 212.27 multiplied by 9 cubed minus 658.019 square, that is the current year, that is the 9th year, plus 31033 9 to the power of 1. Therefore, the estimated value simplified, then it comes to 380,743, that is 38 lakhs. It is 3,80,743. Hence, the management decides to appoint Mr. X and pay pockets is 38K. End note. Sensitivity to outliers. Polynomial regression equation is sensitive to the outliers. Even one or two outliers can significantly impact the results of the polynomial regression equation. Overfitting. As the polynomial degree increases, the model can become too complex and start fitting even the variables which are too far away and create a random fit. Random variations can be created. Underfitting. If the polynomial function is too simple, it might not capture the data which are in the non-linear pattern and the trend values. Interpretability. High degree of polynomial can be more difficult to interpret and explain than the linear models. Exploratory problem or extrapolation problems, that is the polynomial regression might not be able to accurately predict the value outside the range of the observed data. Thank you very much. Please like it, share it and subscribe it. Thank you very much.